Hey everybody, welcome back to Knowledge Over Grades. This is your favorite math coach, Latrell Jackson, and today we are going to be talking about when to use multiplication in a word problem. So I'm going to help you to identify phrases and words that stand out to tell you that you need to multiply. And this is going to be word problems ranging between elementary math and algebra. If you're ready to get started, go ahead and give me a like and subscribe and tap the bell so that you know when I upload my next video. This one is going to be really good, so let's get started. So you definitely want to look for clue words and phrases in your word problems. And you're going to either need to find the group, which would be the multiplicand, the first number you will multiply, the number of groups which would be the multiplier, or the total number of items altogether, which is the product, which is the answer of multiplying two numbers together or multiple numbers together, okay? So in some of the word problems that may come up, you may find that there is repetition that is being explained. So you're going to have to ask yourself how many of the same thing is being repeated. You also may come into some comparisons and you'll ask yourself what is being compared. Some questions may require you to ask yourself, how many combinations can I make for the possible combination questions? And some questions may require you to use a formula. You may ask, which formula should I use based on the given values? Okay. So you got to be paying attention, and we're going to go through these different categories and the type of phrases that come up in these categories. So repetition. As you see, we have cookies, and there are groups of 2 cookies that are being repeated, and we see they're repeated 4 times, okay? So 2 times 4, how many cookies are there in all? 8. All right, let's look at some words that will bring us to this point where we need to multiply based on repetition. Okay, so each is one of the words that represents repeated addition in a multiplication problem. And we want to ask ourselves how many of the same thing is repeated. For the first example, we can see it says each child had 2 cookies, and that is resembling the picture that we have here. Each set of these cookies belongs to a child, okay? And so we can say that each child had 2 cookies, and there are 4 children. Okay, $25 each at the door. So however many people are coming to this event, they have to pay $25. And the venue is collecting $25 per person. And you see I'm saying the word per, right? That's another multiplication word we're going to go over. So $25 for each person. And if there's 100 people that come, that means 25 times 100 is 250. Okay. 9 levels with 6 challenges each, okay? This could be a video game. 9 levels in the game and 6 challenges on each level. That will require you to multiply. How many challenges are there in all? Okay, the word per, another repeated addition word. Our first example says 60 miles per hour. 60 miles per hour. And the acronym for miles per hour is MPH. And if you see this in a word problem, which will come across another one in this presentation, you know that MPH stands for miles per hour, okay? 12 bottles per pack, all right? So pack is the item that will be repeated, because if you're talking about a grocery store, they're not going to sell just one pack of bottles of water. They're going to sell multiple packs. So how many bottles would they have in all if there are 12 in each pack? Okay, that's the question that will be formulated off of this type of phrase. $50 per session per student. Okay, this has 2 sets of multiplication. How many students are in a session and how many sessions are you going to have? Multiply all of that by 50 and multiply all of that together, okay? For every is another repeated addition phrase, and we're asking ourselves again, how many of the same thing is being repeated? 8 chocolate chips for every cookie. How many cookies do you have? It determines how many chocolate chips you need, because 8 is going on each one of them. $5 for every student. How many students? How many $5? multiply those things together. 10 beads for every braid. So we're talking about, I'll give you a picture of it. Here's a lovely lady with beads in her on her braids, and she is, I didn't count them, but I'm going to guess she has 10 beads on each one of her braids. And we see she has multiple braids. So the question would be, how many beads are there in all? We would have to multiply 10 times the amount of braids. Okay. Now we're moving on to comparisons. Let's see. So we have, by the way, cookies is a going theme in this presentation, as you can tell. We have 2 cookies and we have 6 cookies. So we're comparing the two. Let's see what type of words come up for comparisons and multiplication. All right, so we have twice and double. That represents 2 times 2, right? So let's look at those examples. Double the price, that means whatever the price was, we're multiplying that by 2. We're doubling it, multiplying by 2. Twice the lamps. So let's say in one room there were 2 lamps, and in the living room there are 4 lamps. So that's twice the lamps because we're multiplying the 2 by another 2. Okay? Triple is another word. Triple your income. So we're starting out with a certain amount of money that you're getting every year, tripling that by doing something extravagant, and now you're making triple the amount you were making. That's amazing. Multiplying what your income was times 3. Triple is a 3 word. Quadruple the space. All right, so whatever the space was originally, you tripled your income, and now you have quadrupled the space because you have tripled your income and you can afford more space. You can afford you a mansion now. All right, so quadruple, if we think of quad, remember the 4-wheelers that people ride on? Those are called quads sometimes, we call them that. Quad means 4, quadruple. All right, so we're multiplying the space, the amount of space, by 4. All right, we're moving on to times. So usually when we're talking about these words, twice, double, triple, quadruple, we're not going to go too far past quadruple because I don't even know what the next word is off the top of my head. We just usually go up to quadruple. So after that, we start using times. And we can say 5 times as many, 6 times as many, 10 times as many, okay? So in the example, we have 3 times as many M&Ms. All right, so that can also be triple the M&Ms. That's another way of saying it. 10 times the weight. 10 times the weight. So whatever the weight was, we're multiplying it by 10. 17 times the amount of solar panels. So a house has a certain amount of solar panels, and a field is going to have way more than that. So maybe 17 times the amount of solar panels. All right, so remember that you're multiplying the original by what is being times by. 17 times the original gives you the total, and you're asking yourself what is being compared. Original by the result. The word of is a comparison word, in my opinion. So we're usually multiplying of by a partial number, and that would be by a fraction, a percent, or a decimal, and we're comparing a portion of the whole. Okay, so let's look at some examples. 20% of her clothes. Okay, so we have all of her clothes, right? 20% of them she's donating. Half of those in attendance. So half is 1 over 2, just like that 1/3, that 1 over 3 we have. The half is going to be 1 over 2. That's a fraction. And we're multiplying that 1 over 2 by the total number of people in attendance. So half of the people in attendance left. That can be a word problem. And you have to figure out how many of those people actually left based on the total that you were given. All right, 1/3 of the cookie mixture. So not the whole thing, but 1/3 of it. Let's say 1/3 of the cookie mixture got M&Ms. The other portion did not get M&Ms. All right, you have to figure out how much of the cookie mixture actually got the M&Ms. And let's look at the cookies that we were looking at before. We're comparing them, and let's apply the phrases that we just learned for comparison. So 3 times as many cookies. We're looking at the plate of 6 cookies. The plate of 6 is 3 times as many cookies as the 2 cookies here because 2 times 3 is 6, timesing by 3, 3 times as many. All right, triple the amount of cookies. So we took the 2 and we tripled the amount of cookies and got 6. Or we can say that the plate of 6 cookies is triple the amount of cookies that we had. Okay, and then 1/3 of the cookies. So the 2 cookies is 1/3 of the 6 cookies on the plate. That's how you can apply these comparison phrases to these cookies using multiplication. All right, so we're still talking about comparison, but now we're going to be talking about increase by a factor of. And this actually has a formula to it. We're going to use n is the original amount we're given, times a factor, plus n. We're adding whatever result that gave us to n, all right? So the temperature increased by a factor of 0.3. Okay, let's look at an example. All right, so let's say it's the morning time, and this actually is an example of what happened today. This morning it was 60 degrees, all right? The temperature increased by a factor of 0.3 by the afternoon, all right? So let's apply the formula. Okay, so the formula is n times the factor plus n. So our n is 60 times the factor, which is 0.3, and we're adding that back to the 60, okay? So 60 times 0.3, that's 18. So we know that it didn't go to 18 degrees by the afternoon. That's freezing, that's below freezing. So that means that we have to add that to the 60 because it increased, it didn't decrease. 0.3 is only a portion of the 60, it's 18. Okay, so 18 is being added to the 60 so that we can get an increased amount for our temperature. And our temperature ended up being 18 plus 60, which is 78 degrees. So it is pretty hot in here and I'm a little steamy while I'm doing this video. And that is one example of a comparison phrase when you are doing multiplication, and you'll more likely see this in algebra, high school, higher level multiplication word problems. All right, here's another example. Increase by a factor of 3 fresh cookies. All right, we're using the formula. So I didn't write the formula out, but we have the 2 cookies, right? Increased by a factor of 3, so 2 times 3 is 6. Okay, there are 6 cookies on that plate, but it increased by a factor of 3. That means that we still have the original amount of cookies, the 2, and we increased by 6 more. So 6 plus 2 is now 8. All right, 8 cookies total. All right, so possible combinations. This is when we have a lot of things in different categories and we need to see the different combinations that we can make out of these categories. So we're going to ask ourselves, how many combinations can I make? Okay, so the first one says 4 dressings and 6 salads. So you got 4 salad dressings, 6 salads. How many salads can you make out of those combinations? You're going to multiply 4 times 6. Okay, 6 shirts and 2 pants. How many outfits can you make? Multiply 2 times 6 is 12 outfits. All right. And the last one says 2 appetizers, 3 entrees, and 2 desserts. So that's a little bit different. There's an extra factor in there, but you're still going to multiply 2 times 3 times 2. Let's look at that as an example. So here is an example. Our appetizers are garden salad, chips, and salsa. Have 2 pictures there. Our entrees are veggie bean burger, Thai glazed salmon, and shrimp and grits. And then our desserts are fruit kebabs and peach cobbler. So how many combinations can we make? All right, so here's a diagram of the different combinations you can make. And I drew lines that show you the different 3-course meals you can create out of the options that you have. And it turns out that there are 12 based on all of the lines that I drew. An easier way to do it is just to multiply. So at the bottom you see I have 2 times 3 times 2. and that gave us 12 combinations. So this is like a prime example that shows us that multiplication is actually repeated addition. All right, and now let's look at geometry. Geometry has a bunch of different um, formulas that we need to apply. And what you really need to ask yourself is which formula should I use based on the values that I'm given. Okay, so we're just going to talk about area and volume in this video, but like I said, there are plenty of different formulas in geometry. So for area, the formula is length times width. And for volume, the formula is length times width times height. So you want to ask yourself, which of the values am I given? And how is that going to help me decide which formula to use? So let's look at some examples. The first one says, if the length is 23 feet and the width is 19 feet, how much space is being used? How much space is being used? That's not asking for volume or area. It's just saying how much space is being used. So what you do is you look and see what values are given to you, what dimensions are given to you. You got length and you got width, and that's it. So that means that it must be talking about area. So you can apply the area formula by multiplying length and width together, okay? Then you have, if the length is 4 inches, width is 7 inches, and the height is 13 inches, what is the volume? Okay, so that gives you straight up what formula to use. It says, what is the volume? The thing what you have to do here is to remember that volume is all multiplication. All you're doing is multiplying all the dimensions together, and that gives you your answer. Okay, last one, it uses dimensions. So sometimes we're given just dimensions. It says, it may say A by B or A by B by C, meaning those letters would be numbers. So in this example, it says the floor dimensions of a room are 40 feet by 55 feet. What is the area? So it would be your job to figure out the fact that this is asking you to multiply and that this is, in fact, the dimensions of the room. One is the length and one is the width, okay? All right, now we're talking about grids. What is a grid? A grid is a network of lines that cross each other to form a series of items. All right, so I got part of this definition from Google, and it said that you're going to form a series of squares and or rectangles, but you're not always going to form a series of squares and rectangles. As you see, we're forming a series of cookies, or you can form a series of books or a series of horses or whatever you want to form based on how you line them up. So here we have cookies. They don't look done yet, but they look really good. As you see, I like cookies. I had a little known fact. I was helping my dad with his cookie business when I was in high school, and me and my sister used to make cookies at night and sell them at school to like raise money to go on trips and stuff. All right, so with grids, we're going to be talking about rows and columns or levels. So let's look at the first example. It says 4 rows and 4 columns of cookies. How many cookies in all? So that was what we have on this cookie sheet right here, 4 rows and 4 columns. So rows goes left to right and columns go up and down, okay? 20 rows of 56 seats in the theater. How many seats in total? So that's something that we will multiply, 20 by 56. 8 floors with 10 rooms. How many rooms altogether? Okay, so each floor, there are 8 floors and they have 10 rooms on each floor. So that is something that we would multiply 8 times 10, and that is an example of levels. All right, let's talk about rate. Rate usually uses the words per, for, every, and each, and you will more than likely see per in a rate type of word problem. So let's look at the first example. It says 60 miles per hour for 5 hours. How many miles in all? Miles per hour is that the acronym that's right after 60, MPH. That means miles per hour. So if you're going 60 miles per hour, that means 60 miles for every 1 hour, and you drove for 5 hours. How many miles did you go? That would be 60 times 5. 8 boxes per minute. How many in 1 hour? Okay, that's a little bit different. That's more of a higher level question because you have two different units. One is minute and one is hour. So you have to figure out how many minutes are in 1 hour, and that's what you will multiply by your 8. How many minutes are in 1 hour? 60. So there are 60 minutes in 1 hour, so you multiply 60 by 8, and that's going to give you 480, right? So 480 boxes in 1 hour. Last one is somebody ate 2 cookies every hour. How many in a day? So how many hours are in a day? 24, right? So you're going to multiply 2 by 24, and that's going to give you 48 cookies in a day. That's a lot of cookies. Hopefully, they were small cookies. All right. So as you see, these words we've seen already, every, per, each, you've seen already in previous questions, but for rate, they show up again. So tricky, tricky. Let's see what this is about. Watch out for these phrases. In all, altogether, and in total. Why? Because these phrases appear in addition word problems as well as multiplication. All right, let's see some examples that we actually did use today. So in all, when I said 60 miles per hour for 5 hours, how many miles in all? Sometimes you may see in all and think, oh, I need to do addition. But no, not exactly. You got to look for more word clues in order to really uncover what the operation is you need to use, okay? In all, you still are looking for a total because that's what in all means, in a total. All right, thank you for watching this video. Did I miss any? Let me know. If you have any suggestions or if you have any that you came across that are multiplication phrases, go ahead and put them in the comments. I'd like to see what you come up with. Also, which category do you struggle with the most? Combinations, repetition, comparison, rates, geometry. Let me know in the comments which one you struggle with the most and that you need to practice more of. And also let me know if this video was helpful or not. Thank you so much for watching. I also want you to go ahead and download your pre-algebraic translation guide that I have created for you. It doesn't only have multiplication phrases, but it also has addition, subtraction, and division, and equal, okay? You definitely want to keep this in your binder, have it with you when you're doing your homework and in your classes so that you are able to quickly identify what you need to do when doing word problems, because word problems are not the easiest thing. I'm sure you can attest to that and agree to that. So go ahead, click the link in the description and download that. And if you like this video, go ahead and like it, give it a like, and also subscribe and tap the bell so you'll be updated when I do another video. I definitely want you to catch all of my videos because I know that they can help you, so I spend time on them to give you the best information that you can get on YouTube. So go ahead and subscribe, share this with a friend, and I'll see you in my next video.